Welcome to the first lesson, Big Data, Big Value. This lesson is designed to understand why data is so important in the modern times and advent and the need of big data technologies. As you have reached this course, I hope that you would have already heard many people quote that companies like Facebook, Twitter, Google are generating and working on petabytes of data every day. The Large Hadron Collider near Geneva producing 15 petabytes of data every day. So much so that they are throwing away most portion of the data, hoping that there should not be anything valuable to be analyzed in that. Although these facts are interesting, but fail to show importance of big data to a normal organization. So I would begin with the classic problem of an organization trying to find price of their new product and importance of data to get the optimal price. In this case, the organization would be bank and new product be say insurance. This is a very unsophisticated example to show the value of data to an organization, so please don't mind the attributes which I've taken in consideration. The greatest worry for any organization, in this case, this bank, is to find optimal price of their new product that would generate maximum revenue and is equally welcomed by the market. To calculate the optimal value, bank has lots of internal data around it which might be of help. First is their mainframe repository, which may contain all the customer information and account logs that have generated for so many years. Second, they would be hosting websites, and there are various activities on their websites which can be valuable to understand the market trends and interests of the customers. These can be derived from clicks and people showing interest in particular product on the web page. Third, they have the spending patterns of all their customers that can yield important information to understand and categorize its customer. Along with this internal data that is available, there are external sources also available which would be important for the analysis, like the all-important competitors' pricing. Then social media updates, which would be generated by market research firms analyzing trends from activities on social media. Lastly, third-party statistics, which would give an idea like what is the recent trends in medical problems and expenditure on them, or how many accidents are happening per 1,000 people in a locality. Bank would collect all this information, overlay them on each other, and run statistical algorithm to find the optimal price. In this example, we see how the data acts as a decision support system. The more the attributes taken into consideration, the better would be the decision support system. So more the data, more accurate would be the predictions. At this point, we would peek into the future and see how big data technology is going to change the method of decision making in the future. In future, the data would be the foundation of digital nervous system. What it means is that based on the changes of any of the input attributes, the output would automatically change. Think this like Skynet. Let us understand this with an example. Suppose you update that you are planning a trip abroad on social media. The bank software gets this feedback from its sources, which keeps an eye on social media updates, and so bank software automatically sends offer for travel insurance suited for your travel. Or suppose the competitor changes its price. The price of our bank automatically changes to a new optimal value so as to maximize the profits. This is a futuristic vision of a computer network that imitates the biological nervous system in the following characteristics. First, deciding on what bit of information is important and what is not. Second, learning from experience. Third, adapting to changes in its external environment. Fourth, reacting swiftly to advantageous or threatening situations. So that was about the future. Let us see how the data is used as a decision support system at present in the organization. At present, we use data warehousing, and let us look at the overview of its architecture. There would be multiple sources of data. Each of this would be sampled and cleaned and put into the database known as data warehouse. On top of this data warehouse, the statistical algorithm would run, which would create a report helpful in business decisions. In this architecture, there are two limitations. First, the data is sampled on the basis of attributes and not the whole data was seen. So in this case, we would be looking at a partial data only. This sampling is necessary for data warehouse to function, as if the complete data is considered, data analytics would take days to reach to results. So for this reason, only a sample of data with the most important attributes is considered for data analytics. So it is to like looking through a keyhole and trying to guess the size of the room. Second, the data retrieved from various sources was cleaned and processed just to get it ready for the analysis. So till the point of time the analysis was run, the data was already stale. So the decision hasn't taken into consideration the current situation, which is the most important.